Welcome to the Q&A session 37 from the playlist of JEE Main Physics Part 2. The topic for the today's session is the magnetic field due to a circular conductor. And based on this topic, I have selected one question for this session which is written here on this board. So the question here is, a cell is connected between 2 points of a uniform circular conductor of radius A. So this is the figure which is provided along with the question. So this is the cell which is connected between 2 points of this uniform circular conductor having a radius A. So the magnitude of the magnetic field at the center of the loop is. So there are 4 options here and we have to find the correct one. Now, in order to find the magnetic field at the center of this circular conductor, we will first of all find the potential difference across the point P and R. Potential difference across P and R. Now, in order to find the potential difference across V and R, we will be finding the resistance between the point P and R along this arc, along the arc PQR. So, we know that the resistance is equal to the resistivity of a material multiplied by the length of the conductor divided by the area of cross section here. So here I am just taking the length of the arc PQR as L2 and the length of the arc, that is PR, as L1. So the resistance of the this circular conductor, or you can say the resistance of the arc PQR of this circular conductor, will be equal to, say it is R2. So this is equal to, now the resistivity of this material will be the same for both the two arcs. So this can be written as rho L2 divided by the area of cross section. So area of cross section will remain the same, and in this case it will be equal to rho into L2 divided by pi A square, where A is the radius of this conductor. Similarly, the resistance of the arc PR will be equal to rho L1 divided by area of cross section, and this will be equal to rho L2 divided by L1 divided by pi A square. Now the potential difference across this P and R, or you can say the potential difference across the point P and R will be equal to V, that is equal to the current which is I first of all considering the arc PQR. So that will be the potential difference across P and R. If I am considering the arc PQR, this will be equal to I2, that is the current which is flowing in this arc, and multiplied by the resistance which is equal to rho into L2 divided by pi A square, and this will be equal to, now if I am considering the arc PR, so in that case it will be equal to I1 into rho into L1 divided by pi A square. So from here we can see that This pi a square will get cancelled out, this row will also get cancelled out, and finally what I am getting is that I2 into L2 will be equal to I1 into L1. So this is the first relation which I have got. Now in the arc PQR, the current is flowing in the clockwise direction, and in the arc PR, the current is flowing in the anti-clockwise direction. So the magnetic field at the center O, due to these two currents, will have the direction which will be opposite to each other. The direction of the magnetic field because of this current I1 and the direction of the magnetic field due to the current I2 will be exactly opposite to each other. So the magnetic field at the center of the loop, that is at O, will be equal to the magnetic field due to the current I2 which is flowing in the arc PQR. So this will be equal to mu naught upon 4 pi, and this will be equal to I2 into L2 sin 90 divided by a square, and minus mu naught upon 4 pi. I'm writing it in here, minus mu naught upon 4 pi into I1 into L1 sin 90 divided by a square. So here minus sign has been taken because the direction of the current in these two loops, that is PQR and PR, are opposite to each other, and because of that the direction of the magnetic field at the point O will be opposite to each other. That is the direction of the magnetic field due to the current I2 and the direction of the magnetic field due to the current I1 will be exactly opposite to each other. So this will be equal to what? Now here I2 into L2 is equal to I1 into L1. So if I2 into L2 is equal to I1 into L1, then the magnetic field at the center of the loop will be equal to 0. So thank you very much for joining this session. And in this session, the most important thing which we all have to remember is that in solving this question, we have used the formula, that is the resistance is equal to resistivity multiplied by the length of the conductor divided by the area of cross section. So with the help of this formula, I was able to get the relation, that is I2 into L2 is equal to I1 into L1. And with the help of this relation, we were able to find the magnetic field at the center of this conductor. So thank you very much again, and in the next session I will be coming up with another topic which will be completely different from what we have studied today. So till then, have a nice day. Bye.